Hello, today I'm going over Isotope Practice Worksheet, and it talks about isotopes and what isotopes are and a little bit about atomic decay. But the general idea here with isotopes is it's an element that has a different number of neutrons or a different mass. So for instance, I've got hydrogen here with one proton and one electron. Well, here's another form of hydrogen. It's still hydrogen because it only has one proton, but now it also has one neutron, still only has one electron. And then a third type of hydrogen, another isotope of hydrogen, one proton, just like all these others. That's why it's hydrogen, but now it has two neutrons, still only one electrons. So these are the isotopes of your hydrogen. What we're going to do down here is fill in these charts, and for each table we have two different isotopes of an element. And so we're going to fill in the number of protons, neutrons, and electrons for the different isotopes. All right, so chromium. First thing we need to do is know how many protons chromium has. Well, here's chromium. It's atomic number 24, and 24 also tells us that there's 24 protons. So I go here, number of protons for chromium, 24. I'm gonna have a matching number of electrons in these circumstances. So for this table, the number of electrons is gonna always be the same as the protons. Next, I have chromium 63. It's still chromium, so the number of protons is still the same. It's still 24. So I go 24. If there's 24 protons, 24 electrons. So that's the easy part. Now I have to figure out the neutrons. Well, the general formula for figuring out neutrons is this: protons plus neutrons equals the mass number. And that's what 58 here is the mass number. So I'm going to do a little calculation. I'm going to take, since I don't know the neutrons, I'm going to take the mass number, 58. I'm going to subtract the number of protons, which is 24. And that will give me 58 minus 24 is 34. Now on this chromium, we have a different mass number, 63. So this has got more neutrons. It's heavier. I can solve this though again by taking the mass number, 63, subtracting the number of protons, and that will give me the number of neutrons. So 63 minus 24 equals 39. And you're going to do that same procedure for all of these other ones. I'll do one more example over here with the carbon. So I find carbon on my periodic table up here, and it has an atomic number of 6. So that means it has 6 protons, and in our case here, 6 electrons. It'll be the same for these, because it's still carbon, but I got to find out how many neutrons. Well, here's my mass number, 12, minus my protons, 6, equals my neutrons. 12 minus 6 is 6. There you go. So do the same thing over here, and for the rest of these, let me know if you have any questions. Thanks.